Now let's look at developing the prediction interval and confidence interval for y for a given value of x sub 1 and x sub 2. So we already looked at the case of computing a point estimate. Suppose we want to look at the estimate for sales of omnibars when we set the price per bar at 79 cents and in-store promotional expense at 400. So early on we computed that right here, but that's only a point estimate. What if we want an interval estimate? Now this topic is not covered in your text because the computations are rather cumbersome, but there is a small trick that we can use with Excel data analysis regression command that will generate our confidence interval and prediction interval for us. It generates a prediction interval. Once we have the prediction interval, then we can calculate the confidence interval from that prediction interval. And here is the trick, and you have to follow this very carefully. So what we're going to do is we're going to go back to the original data. Okay, so we have the sales, we have the price, we have the promotion, right? So we're going to add a new column and a new row, and we'll call this prediction. Okay, then we enter a value of 0 for this new column all the way down. Okay, so let me use a background to indicate that this is a new column that we are creating. Okay, and then we're going to add a new row. So we get one additional column and one additional row. And this additional row, we need to put a -1 here. Okay, and for sales, we put a 0. And here are the x sub 1 and x sub 2 columns. So enter the values of x sub 1 and x sub 2 for which we want the estimates. So we want 79 cents as price per bar and 400 as in-store promotional expense. Now we're going to run the regression command. Okay, this is using the new expanded data. Okay, so we go to data analysis, regression. Okay, now for y range, so we go from K11. Now this time we have to include the newly added row as well. And for x range, so we start from here. Now we have to include the newly added column as well as newly added row. Okay, then we don't need any residuals here, so uncheck the residuals. First row is labeled, so we'll put the output somewhere over here. Okay, I think that would work. Okay, now this time the regression generates one additional row for coefficients. See, in the earlier case there were only 3 rows: intercept, price and promotion, which we have here, and in addition we have prediction also. Now the numbers that you see here are true for the prediction interval. So that's our point estimate. This is standard error for prediction interval, and the lower and the upper limits are the prediction intervals. So let's assemble them here. So y hat is that. Okay, and then the lower limit of our prediction interval is lower limit. Okay, and then AP, so this was AO31, AP31 will give you the upper limit. So this is our prediction interval. We can provide an interpretation. Now this is a prediction interval, remember. So for a price of 79 cents and in-store promotional expenditures of $400, a given store, okay, the sales will be between these two numbers at an individual store. If you want confidence interval, then okay, let's assemble what we already have. So y hat is that. Now suppose we want 95% confidence interval. So the degrees of freedom comes from the MSE degrees of freedom, which we can get from any one of these regression output that we have already generated. So the MSE degrees of freedom. So T table value will be T dot INV dot 2T and 1 minus confidence levels, that's our alpha value, and then the degrees of freedom. That gives us the T table value. Now what we want is the standard error for confidence interval. Then we will have the margin of error by multiplying T and the S. But to get the confidence interval's standard error, okay, we need the standard error of the individual prediction interval. The regression output we have generated, okay, the standard error for that prediction, this is the standard error for prediction interval. From that we have to derive the standard error for confidence intervals. So for that we need the MSE value. So let's get the MSE value. Once again, you can get the MSE value from any one of the regression outputs that we have generated. So that's our MSE. Then this is the formula for the standard error for confidence interval. So we have square root of, you take the individual prediction and standard error for prediction interval, square that and subtract MSE from that. So that gives you the standard error for the confidence interval. Now multiply T table value with the standard error. That gives us the margin of error. So y hat minus margin of error is the lower limit. Y hat plus margin of error is the upper limit. So this is our confidence interval for sales. The previous one that we got from the output is the prediction interval. Now this one is confidence interval for mean. The confidence interval is for, so this is for mean. The confidence interval is for mean. So we are 95% confident that the average Omnibar sales at all the stores, okay, based on a price of 79 cents and in-store expenditure of $400 will be between these two numbers.